gonna record the lesson so that I can share it with the rest of the class so that they don't miss out. I have my wrong science textbook, so let me go back and grab it, the right one. So we're in chapter 16. Do you have any questions about the atomic models before we start?
Hold on. Chapter 16.
Yes.
Wait, we had homework last night.
Yes.
Okay.
So you want to go over that with me first?
Yes.
Okay. So, question number 1. What is the most important aspect of a scientific model, and why has the model of the atom changed?
Because well, I mean, like the first part is it workable?
Yep, perfect.
Alright.
Workable and provides useful answers.
Alright. The second one is I'm not very sure it's correct, okay?
Mhm.
Because they keep discovering more about atoms, so the models have to change to like study the atom.
Yeah, exactly. So they kept discovering more. They found electrons and they found protons and they found neutrons. So every time they discovered more about the atom, they had to make it the model better so that it was more workable and provided answers better. Good job. What part of the Greek model of the atom has been set aside by current scientific knowledge? So answer that part first.
I think it's also wrong that the atom cannot be divided.
Yeah, that's one part of it.
And the second part is it light?
What do you mean? The second part of the first question
Yes.
is like, yeah, pretty much. So they believed that everything was made out of atoms, even light, and your thoughts, and your soul, everything. And they believed that the atom was eternal. So the atom has always existed since the beginning of time. And then the second part, what part of the Greek model can be refuted by scripture?
Oh, can I look back? Okay. Alright. Okay, so we know from later observation, for example, that some things that exist like light are not made of material particles like atom. More importantly, we know from scripture that atoms have not always existed. God created them at the beginning of time.
Perfect. That's exactly what I was looking for.
Okay.
So we know that God created a beginning physical universe. So he would have created atoms during the creation of the universe. That's what we believe. Okay. How did the ancient Greeks differ from European scientists in their pursuit of knowledge about the world, especially the atom?
So like they're different because one, they want to so like I think the Europeans they use experiments that they don't even know, and Greeks I think they just have to look back.
No, I think you're right. So just say what you wrote.
Oh, they study it.
So you said the Europeans didn't do experiments and the Greeks did? Was what you said?
Well, like I didn't write that, but I guess so.
Oh. Yeah, I think you would use the word studied.
Yeah.
Okay. So let me get it straight for you. So the Greeks, remember Aristotle and how we talked about how Aristotle thought all of these things and people just believed him? And then later scientists did experiments and then they proved Aristotle's ideas to be false? Okay, so Aristotle is a Greek philosopher. And so the Greek philosophers, they didn't do experiments. All of their ideas were based off of their reasoning. So if it made sense and it sounded good, they accepted it without experimentation. The Europeans, however, did experimentation to prove things. Does that make sense? Okay. So Greeks, they're like the philosophers and they just had ideas. And the Europeans did actual experimentation for their thoughts. Okay. That's why when we talked about Aristotle and all of the other Greeks, we were just like, this guy thought, this scientist thought. But then when we started talking about the European scientists, we talked about all of the equipment that they used and the vacuums and all of that, because they were the European scientists that did experiments. Okay. Discuss one aspect of John Dalton's atomic model that was set aside by later discovery.
Okay, this is like totally pretty wrong because Zygmunt told me this answer, so I'm gonna have to work like. Wait, hold on. Maybe I'll just read this because it might be right.
Okay.
I wrote like. Actually, no. This has to be wrong.
So okay. Let me show you where you would go to find this. So if you go to page 356, we have all of the things that John Dalton believed. So he believed that an atom cannot be created or destroyed. He believed that the atom cannot be subdivided into smaller particles. Elements are made of only atoms. The atoms of an element are all alike. The atoms of one element are different from the atoms of all other elements, especially their masses. And then he also believed the core envelope model, that was that an atom is like this, where you have the core and then you have a heat envelope around it, remember?
Yeah.
So this was his model. So the two things that John Dalton believed that later other scientists proved to be false, well, one of them was the heat envelope theory, right? Because later on, they started to find neutrons, protons, and the core ended up being called the nucleus, and then the heat envelope ended up to be this cloud of electrons. So he believed, so that was refuted, basically means that it was proved to be false. And then he also believed that the atom could not be divided, but then later on, we found the subatomic particles, neutrons, protons, and electrons, so it can be divided. So those were the two things you could have said. What was the most significant question about the atom after Thomson's discovery of the electron?
Can atoms be divided?
So the most significant question about the atom after his discovery was, can it be divided? That's your answer? I'm just asking. Okay, no, that's fine. So after Thomson discovered, he made his discovery, so he found that they had these electrons, right?
Mm-hmm.
But then they found out that the electrons don't have much mass. So after he found the electrons, the question was, what makes up the mass of the atom? There must be something else because the electrons don't have mass. So that was the question. What made Rutherford conclude that the nucleus was an extremely small part of the atom?
Because some atoms were small and some atoms bigger.
Not really. So do you remember that apparatus that I showed you and they had that gold foil? We said that some of the atoms bounced off, but then some of them went straight through the foil.
Mm-hmm.
So he said that there must be a lot of empty space in the atoms that allows other particles to slide through the atoms. Because if the atoms were big and had this bulky nucleus, then what would happen would be if the particle came, it would bounce off of the nucleus. But that's not always what happened. Sometimes it went straight through the other atoms. So they said that it must have been a lot of empty space and the nucleus must have been small. What phenomenon did Niels Bohr observe that convinced him that every atom has a unique electron structure?
Because they can change colors.
Yes. And so they found that they emitted different unique arrangements based on the colors. How do orbitals in the quantum model of the atom differ from orbits in the planetary model?
I don't know this one.
That's okay. So in the quantum model, they had 3D locations for where the electrons were going to be. In the planetary model, they didn't really, if you look at it in the book, it's like flat, and they were just arranged on these circles around the nucleus. But then the quantum model said, instead of being like dots on the outside of a 2D ring, that they're actually in these either spherical or dumbbell-shaped 3D orbitals. Which, I'm not gonna ask you a whole lot about that, so no, because that's like a whole bigger can of worms about quantum theory and stuff that when you take chemistry in high school, that they're gonna talk a lot about. So just understand the idea that electrons reside in these like 3D clouds almost. But then later on, when you're in chemistry, you're going to learn what those clouds are, what their names are, and all of that. So, but I want you to just know there are clouds so that when you go get into that deeper, you already have the foundation, okay? So just know that at least. The Bohr model of the atom is wrong, true or false, and the quantum model is correct.
Is it false?
Yeah, it's false.
Okay.
So each model is correct for whatever purpose it's fulfilling. No model is completely correct, but each is workable in that it provides useful answers for certain questions about nature. Remember, we are human, so our knowledge is finite and imperfect. So we can only know as much as our research allows. And we base our research and we try to ask good scientific questions, but we're imperfect. So there's no way for us to know that our model is ever going to be completely finished, because we could discover even more later on. There's an infinite amount of information in the world, and no man, I think, will ever find everything that there is to know.
Yes.
Okay, so now we're going to talk about the orderly atoms. So we talked about all of the different models and all of the different discoveries. And now we're going to talk about what the subatomic particles are. Now, pay very close attention to this part, because the next chapter we're going to talk about the periodic table. And a lot of the information that we're going to see on this part is going to be on the periodic table. So I'm going to grab you, I have a paper periodic table in the back, and I'm going to grab it for you so that when we're going over it, I can point some things out and introduce it to you. But a lot of this stuff you don't have to actually be able to use the periodic table until the next chapter. Here's that for you.
Thanks.
You're welcome. Okay, so we're going to be starting on page 361. So atoms are made out of three principal particles. So what should go in on your notes is that the three principal particles are protons, neutrons, and electrons. And then we're going to give you details about each. Okay, so we have our three principal particles. So, under protons. These are going to be located in the nucleus of the atom, the very center of the atom. Their mass is going to be 1.6726 times 10 to the negative 27 kilograms. Now, have you seen these 10 to the negative 27s before in math class? Okay, so 10 to the negative 27, that means there's 27 zeros before the 1. So if I were to write it out, I have to write 27 zeros and then 16726. Okay, and that's the decimal. So this is a tiny, 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 tiny number. Okay, so the mass is essentially nothing. Okay, we're going to say that a proton has a mass of 1 atomic mass unit, and I'm going to tell you why. But it's this tiny number. In reality, it's that much of a kilogram.
That is pretty small.
Yeah, so tiny. So we're going to say that it's positive fundamental electrical charge. So the charge that it has in the atom, and remember the charges are going to be important for chemical reactions. Based on the charges, they're going to react in a certain way, and we're going to get into that later. So it is a positive 1 charge. They are very stable, so they don't break down a lot. So essentially the proton was created and the proton still is the same way that it was when it was created. So it's a very stable particle. So next we have our neutron. These are also located in the nucleus. Again, they were discovered last. They were the most difficult to find because they do not have a positive negative charge and they don't really do much in a reaction. So they were really difficult for scientists to find with their experiments. So we call neutrons and protons being in the nucleus a nucleon, okay? So protons and neutrons together we'll call a nucleon because they're both located in the nucleus. Neutrons can sometimes be outside of the nucleus. We call those free neutrons, but after about 15 minutes, the neutron breaks down and won't actually be living outside the nucleus. So when we talk about neutrons, we're going to say the neutron is in the nucleus. So we're not really going to consider these ones that only live for 15 minutes outside of the nucleus. So when they break down, they turn into a proton and an electron. So if a neutron breaks down outside the nucleus, it turns into a proton and an electron. This has slightly more mass than a proton, but it's pretty insignificant. So we're also going to say that a neutron has a mass of 1 mass unit, and we'll talk again about that later. So it breaks down into proton and electron when outside the nucleus. So the nucleus helps the neutrons help the nucleus stay together, because remember how we talked about with magnets that like charges don't want to be next to each other? So positive values do not want to be next to each other. So if you have this nucleus and you have all of these positive charges, these neutrons kind of go in between the positive charges to kind of keep the balance and keep the protons in there and not letting the neutrons, the nucleus break apart. If these neutrons were not there, the protons would just repel each other and they would not be able to stay in the nucleus. Then we have the electrons. What was your question?
Wait, so are magnets made out of neutrons and protons?
Magnets are that's like a whole separate thing to talk about. Magnetism is a type of energy. but it is anything, any kind of matter is attracted to each other because of charges, positive charges and negative charges. And the positive charges and negative charges that matter get is from like gravity, from negative charges, from positive charges, but magnetism, I don't know why this just happened. I think somebody's PowerPoint connected to my board. Interesting. Okay, be right back. I think they put their PowerPoint onto my, so weird. It's not gonna let me connect to it. That is so weird. She connected herself to my PowerPoint and so now it's not working.
This happens a lot, which is pretty annoying.
I don't know how. Cause like I don't know how it let her connect when I was connected, you know? No, it's not letting me. There we go. Oh, that was weird. We're gonna talk about the electrons and we'll be done for the day though.
Okay.
Okay, so what you need to know about the electrons, I think we'll just have to go through it without the PowerPoint. The electrons, they occupy all the space that's around the nucleus. So around the nucleus, there's going to be this cloud of space, and inside that, there's going to be these electrons. And they're going to be inside of their own little spaces, because just like the protons would repel each other, the electrons repel each other because they have the negative charge. They don't want to touch each other. So they each have their own space that they occupy around the nucleus. Now their mass is 9.11 times 10 to the negative 31 kilograms. So they do have mass because they have to have mass in order to exist. But it's so small that we kind of just consider it to be zero because it's essentially nothing.
Wait, do we have to know the mass?
I wrote it down.
Okay.
Everything on the PowerPoint is fair game for quizzing purposes. I might ask you something like, does an electron have mass? And the answer would be yes, but it is so small, we don't really consider it. But it has to have mass in order to exist. So that's what I want you to have in your head. So this one's gonna have a negative charge. So we're gonna say it has a negative 1e, and that E stands for electrical charge. So this one is responsible for the chemical properties of the atom. So any of the properties that an atom has that will make it react, any reactivity is going to be because of the electrons doing something. And we're going to talk all about that. But when we talk about electrons moving between atoms, that's what causes chemical reactions. So anytime you are mixing things together or you have electricity or anything, it's this movement of these subatomic particles that matters. All right. So I will talk about atomic number, atomic weight, and all of that on Monday. And then the electron arrangements and all that, because that's like a bigger topic and class is almost over. But good work today.
Alright,